Very good morning to one and all. Welcome to DT Studio. Myself, Prashanth Kumar AP, working as HOD, Electronics and Communication Engineering Department, Aryabharathi Polytechnic, Tumkuru. Today, let me discuss the unit number 5 of Microcontroller and Application. And the title of the chapter is Counters, Timers, and Serial I/O. Let me move to the syllabus and scheme of this unit number 5. Here, it's a 8 hours chapter, and according to scheme, you can expect 20 marks. And in the part A, you can expect 5 marks, 2 questions, so totally 10 marks. And in the part B, you can expect 10 marks, 1 question, so totally 10 marks. Means 10 plus 10, totally 20. It carries totally 15% of the whole marks weightage. And this is the syllabus. Here, first we enter to the bit structure and function of TMOD and TCON registers. Then mode 1 and mode 2 operations of timers, counters, time delay generation, and example programs in both assembly language, ALP, and also C language. And then in the second part, we can enter to the bit structure of and function of SCON register, SBUF register, TA and RA flags, working of serial port, connecting 8051 microcontroller to the RS-232 port, and some examples. So here, before going to the what exactly TCON, TMOD, and all those registers, first we should know what do you mean by counter and timers. So here, many of the microcontroller applications, they need to count some external events. For example, consider your domestic washing machine. Each and every domestic washing machine normally it will perform 3 operations or 3 events. The first one is called as the soaking of the cloths, and second one is the washing of the cloths, and last one is the drying of the cloths. These 3 are the best example for the events, because the whole washing machine is controlled by the microcontroller. So in between each and every event, there is some time. For example, for soaking it around 10 minutes, for washing it's around 20 minutes, and for drying it's around 5 minutes. So here, all these 3 events are counted with the help of the counters. That's why counters are used to count the events, external events. Similarly, between each and every event, there will be a time gap or there will be a time delay. The time delay is generated with the help of the timers. See here, to count the number of external events, we are always using the counters. Similarly, to generate the time delay, how much time we want between each and every event, to create that time delay, we are using the timers. This is the basic definition of the timers and counters. And here, in 8051 microcontroller, it basically consists of 2 16-bit up counters, and 2 timers. 2 16-bit up counters. Up counter means it start counting from 0, end with 50. Similarly, 2 timers. So both are generally or commonly mentioned as T0 and T1. And here, why there is a common word for both the counter and timer means in 8051 microcontroller we can program that counter may be act as a timer or sometimes it may be act as a counter. So there is a different program, that means a dual purpose. There is a one device, we can program it as a counter or we can program it as a timer. Depending upon the program, it will count the events, or in the another program, it may create the gap between the events or time delay between the events. See here, this 16-bit counter or timer. I told you there are 2 counters are there, T0 and T1. Similarly, 2 timers are there, same name T0 and T1. Fine. Here again, the 16-bit counters or timers further divided into 2 8-bit registers. 2 8-bit registers. 8 plus 8 again it becomes 16. Okay. That 2 8-bit registers are named as, the first one is called as the timer low. So in the again timer low, there will be TL0 and TL1. Here TL means timer low 0, timer low 1. And similarly, timer high 0, TH0, and timer high 1. Means 16 bit is again divided into two 8 bits. Okay, for example, just see here in this picture. Here, okay, we start from the D0. D0 means bit 0 and end with the D15. D15. So from D0 to D7, from D0 to D7, it is called as the TL0. TL0 means timer low 0. And remaining from D8 to D15 is called as the TL1. Means timer low 1. This is called the first timer, T0. Similarly, for the second timer T1, so this is called as the TH0 and this is called as the TH1. These are the least significant bits. These 8 bits are there, no D0 to D7. These are the least significant bits, and from D8 to D15, they are the most significant bits or higher bits. So that whole 16 bits counter is again divided into two 8-bit counters. Two 8-bit counters. One is called as the timer low, and another one is called as the timer high. And here it may be a timer or counter in case of the microcontroller. So the operation or working of the timer and counter is controlled by the two resistors. One is called as the TMOD resistor. TMOD is nothing but here timer mode resistor. T means timer, MOD means mode resistor. And another one is the TCON resistor, timer control resistor. Or activity or operation of the counters or timers is controlled with the help of these two resistors. Here, now we are entered to the what exactly timer mode resistor. So basically, it is a 8-bit resistor. Already I told you, it is an 8-bit resistor. See here, there are 8 bits are there, starting from the D0 to the D7. Again, these 8 bits are divided into two nibbles. You might have known that one nibble is nothing but 4 bits. See here, D0, D1, D2, D3, it forms the one nibble. This is called as the lower nibble. This is called as the lower nibble. The beginning 4 bits is called as the lower nibble, and the remaining 4 bits is called as the higher nibble. Basically, it's a 8-bit resistor. 8-bit is again divided into two nibbles. One nibble is equal to how much bits? 4 bits. So that these 4 nibbles control the timer 0. I told you there are two timers. One is the timer 0, another one is the timer 1. So these 4 bits controls the timer 0, first timer, and the next nibble, it controls the timer 1. Means, just see here, these 4 bits having the same name. In this nibble also, in this nibble also. The first bit is called as the M0, second bit is called as the M1, third bit is called as the C bar T, and fourth bit is called as the K. In the second nibble also, same naming is there. So here, in each nibble, this lower 2 bits means this M0 and M1, they are called as the lower 2 bits. Here also M0 and M1 are the lower 2 bits. They are used to set the timer mode. In the next slide, I will going to explain the timer can operate in 4 different modes. Any timer, timer 0 or timer 1, it can operate in 4 modes. So that mode is decided by these two lower bits. These two lower bits means M0 and M1. Then the remaining bits, C bar T and gate, okay, they will decide the operation of the timer, how the timer will act. Here, first come to the first 2 bits, that is the M0 and M1. You already know that when there are 2 inputs are there, or when there are 2 bits are there, 4 combinations are possible: 0, 0, 0, 1, 1, 0, 1, 1. Okay, similar to the basic logic gates. So when M1 and M0 are 0, then the timer acts in mode 0. Already I told you there are 4 modes in time in which the timer will act. So in 0, 0, the timer will act in mode 0. Mode 0 is nothing but the 16-bit timer acts as 13-bit timer. Similarly, in the 0, 1, in the case of 0, 1, the timer acts in the mode 1. Means it acts as a 16-bit timer. Similarly, in the third case, that means the 1, 0, the same timer acts as in the mode 2, means it acts as the 8-bit auto reload. I will tell you what exactly meaning of the auto reload. Similarly, in the last case, when M0 and M1 both are high, that means the timer will act in the mode 3. Mode 3 is nothing but it's a split timer. The timer acts as a split timer. So, but here among these four nodes, this mode 1 and mode 2 are widely used, means popularly or commonly used, mode 1 and mode 2. And in mode 3, why it is called as the split timer? Split means nothing but divider. So here, mode 3 is the advanced version of the mode 1 or improved version of the mode 1, because in mode 1, the timer acts as the 16-bit timer. Correct? No? 16-bit timer. Similarly, in mode 3, the same 16-bit timer is act as two 8-bit timers. That's why it's called as the split timer. Split means 16-bit timer is divided into two 8-bit timers. That's why it's called as the split timer. In these four modes, the timer will act. Among these four modes, the mode 1 and mode 2 are popular modes, or they are widely used. And next we are move on to the previous section, because M1 and M0 we are discussed here. Now we are move on to the what it will do. This is D2, that means C bar T, and D3, that means gate. What it will do? See here, C bar T means C means clock, T means what? Timer. In TMOD register, this bit C bar T is there. No, this bit specifies whether it acts as the timer or counter. Because beginning I told that we can program in such a way that it may act as the timer or it may act as the counter. So here, so this bit C bar T, that means clock bar timer bit, it will decide that whether it acts as a timer or whether it acts as a counter. Timer means whether it creates the delay between the events. Counter means whether it will count the external pulses. So that this bit will divide. So now here you can easily know that if C bar T is equal to 0, since it's a binary, okay, either 0 is possible or 1 is possible. If C bar T is 0, then it acts as the timer. Very simple. It acts as the timer and generates the what? Time delay between the events. If the same C bar T is 1, then it acts as the counter. Very simple. Okay. And now the last bit, that is the gate. Here, the gate is commonly used to start and stop the timer or counter, because timer is nothing but there is a limit. We should start from the initial value, we should end up with the final value. Similarly, counter is having the limit. It should count some start from initial value and end up with some final value. So that how to stop and start the timer? So with the help of this gate bit, that is the last bit. So here, this bit is used to stop and start the timer. So if gate is equal to 0, if that particular bit is 0, if you are programmed to 0, then we should use these four instructions. See here, set B TR0, set B TR1, CLR. CLR is nothing but here clear TR0, clear TR1. Please remember, TR0 is nothing but the timer 0, first timer. TR1 is nothing but the timer 1. So when gate is equal to 0, in the program, in the microcontroller program, we should use these four instructions. Set B TR0 means set is nothing but the start the timer 0. Set B means bit here. Set bit, so that it will become what? 0 set agate, so that it will start the timer 0. Then set B TR1, it will start the timer 1, second timer. If you want to stop the timer after counting or after creating delay, then use the CLR TR0. CLR is nothing but the clear, means stop the timer 0, and here again CLR TR1. TR1 means timer 1. So that we should follow these four instructions in the program if the gate is equal to 0. If the gate is equal to 1, what happens? Instead of using this instruction, we should start and stop the timer by using the external hardware switches. Like in our houses, we are using the hardware switches to on and off the lights. Similarly, here also, if the gate is equal to 1 instead of 0, we should not follow these four instructions. Instead of that one, badlagi, we should start and stop the timer externally by using the hardware switches. Okay, so then each and every bit having their own function. These two bits, they can what decides the modes of the timer or counter. 4 modes are there. In which mode it will operate? Commonly, mode 1 and mode 2 are widely used. Then C bar T, that's why it's called as the counter bar timer. Sometimes it's also called as clock bar timer. It will tells that whether it acts as a timer now or whether it acts as a counter now. Then finally gauge. To start and stop the timer, we are using this gauge bit. So similarly, the same bits are repeated here. This is about the TMOD register. It will control the activity of the what? The timer or counter. Similarly, next we are moving on to the TCON register. Full form of TCON is nothing but timer control register. So here it is also 8-bit register. Just see here. There are 8 bits starting from D0 ending with D7. It is very easy to remember these bits. For example, see here IT0. Okay, there is one space IT1. It is related to timer 0. It is related to timer 1. Similarly, IE0, IE1, IE0, one space IE1. It is related to timer 0. It is related to timer 1. IT0, IT1. This is the one page. This is the one page. IE0, IE1. This is the another page. This is the first page. This is the second page. Similarly, TR0 and TR1. This is the one page. R0 is again here nothing but what? It's a timer 0. R1 means timer 1. Then TF0 and TF1. This is the fourth page. Like this, you should remember it is also a 8-bit register starting from D0 ending with D7, and D0 is nothing but IT0, D1 is nothing but IE0, IT1, IE1, TR0, TF0, TR1, TF1. So here, what exactly this first pair? First pair is nothing but what? IT0 and IT1. These two bits, IT0 and IT1, that means D0 and D2, are called as external interrupt mode selection bits. External, please remember this one word, external interrupt mode selection bits. You already studied that this 8051 microcontroller supports 2 external interrupts. Interrupt is nothing but what? It's just like a signal. It will disturb the execution of the program, or it will stop the execution of the program. That's why it's called as the disturbance signal of the interrupt. That's the interrupt now. Okay, 8051 supports 2 interrupts, 2 external hardware interrupts. The first one is called as the INT0, INT1, interrupt 0 and interrupt 1. These 2 interrupts are there, no external hardware interrupts. Okay, they may be level triggered or they may be edge triggered. Okay, trigger means activate. They may be activated at a level. For example, level is nothing but just imagine it's a clock pulse. Just imagine it's a clock pulse. See here, this is called as the level. This is called as what? Rising edge. This is called as the rising edge. This is called as the falling edge. Okay, this is called as the leveling edge. Okay, so that these interrupts, they may be activated at this level, or they may activate either at the positive edge or they may activate at the negative edge. Means they may activate at rising edge, they may activate at falling edge. Okay, so that here now you come to the perfect picture that if IT0 and IT1, these 2 bits, IT0 and IT1 are set to 0. If they are both are 0, IT0 and IT1 are 0, then these 2 interrupts are triggered at that level. They are called as the level triggered. Okay, if the same IT0 and IT1 are set to 1, another combination, okay, then these 2 interrupts are level, this edge triggered. If they are set to 0, then they are level triggered. If they are set to 1, then they are what? Edge triggered. Edge triggered means they are triggered at the positive edge or they may trigger at the negative edge. Positive edge means rising edge of the clock pulse. Negative edge means falling edge of the clock pulse. See here, how to set it a 1? This IT0 and IT1, how we can set into 1 by using this instruction in the microcontroller program. Set B space TCON dot 0. Set B, set that bit. B means bit. Space TCON. It's a timer control register, no? TCON means timer control register. So it is in which bit position? Bit position of 0. Means D0. So that 0.0. And set B TCON 0.2. It means this is the D2 position. That's why set B TCON timer control register 0.2 means it's in D2 position. So that here finally, so if IT0 and IT1 are 0, then both the hardware interrupts are their level triggered, and if the same IT0 and IT1 are set to 1, then they are edge triggered. Then we have moved on to the next it's called as IE0 and IE1. Okay, this IE0 and IE1 are called as interrupt in service flags. Interrupt in service flags. What exactly the meaning of interrupt in service? Interrupt in service. See here, in the microcontroller, if these IE0 and IE1, if they are raised to 1, if they are set to 1, okay, if they are already set to 1, then it indicates that already an interrupt is being serviced. Yado one interrupt already kelsa martide. It is under service. Okay, so that it will not allow any new interrupt. It will not allow any new interrupt till the present interrupt is completed. Okay, when this IE0 and IE1 are set to 1, then only it indicates that already some interrupt is being serviced, so that it will not allow the new interrupt. And once the interrupt service has been completed, what already is executing, no, if it is completed, then IE0 and IE1 is cleared. First we should clear before allowing the new interrupt. First we should clear that IE0 and IE1 by using the instruction RETI. RETI is nothing but return to interrupt. Okay, so that once the interrupt service has been completed, this IE0 and IE1 still they are 1. We should clear by using this instruction RETI, return to interrupt instruction. So that clear means they are what becomes 0. IE0 and IE1, IE0 and IE1 they become 0. Clear. So that now it will allow a new interrupt from the interrupt pin. Until it is 1, it will not allow any new interrupt. It is servicing the present interrupt only. That's why it is called as interrupt in service flag. Once the present interrupt has been completed, then we should clear that IE0 and IE1. Clear means make them as 0. Make them as 0 by using this RETI instruction, return interrupt instruction. Once it becomes 0, IE0 and IE1 become 0. Then they are ready to take the new interrupt. Okay, this is about the next pair of bits, that is IE0 and IE1. Now we are moving on to the third pair of bits, that is the TR0 and TR1. These two bits are called as timer run control bits. Timer run control bits. As the name itself indicates, to start the timer and to stop the timer. Okay, these two bits are used. For example, TR0 is nothing but it's related to timer 0. It is related to timer 0. Timer or TR1 is related to timer 1. Fine. If TR0 is equal to 1, it starts the timer. If TR0 is equal to 0, it stops the timer. Like this. If TR1 is equal to 1, it starts the timer. If TR1 is equal to 0, it stops the timer. Like this. With the help of these two bits, TR0 and TR1, we can control the beginning and ending. Means the start and stop of the timers. And we are moving on to the last pair of bits, that is the TF0 and TF1. These are called as timer overflow flags. It's very interesting. These two bits are very interesting. TF0 and TF1. Because already I told you, here in microcontroller it will support two 16-bit timers. Correct? No? 16-bit means, so the counting start from 0000h to the maximum of f. See here. Okay. This is called as the initial value. 000h is called as the initial value. F is called as the final value. So what happens means the timer start counting from this initial value, and once it is entered to the final value f, then it rolls back to the same initial value. It rolls back to the same initial value. Okay. At that time, this TF flag will become active. Active means TF flag become 1. They set it to 1. If that 1 indicate it completes the counting till the final value, it completes the counting till the final value, then it return back to the initial value. Okay, start the counting from the initial value. It will count up to final value. Once it reaches the final value, it will roll back and it will come back to the initial value. At that time, this timer overflow flag. Overflow is nothing but it's already reached to the final level. It's already reached to the what? Final level. So that it come back to the initial level. At that time, this TF0 and TF become what? They become active. Active means they become 1. That's why here, when the timer overflows, means rolls over from the terminal count to the terminal count means FFFH to the 00H. Then the TF0 and TF bits set to 1. Set to 1 means they become what? Active. This is about the last 2 bits. So that now once again we rewind the 8 bits here. IT0 and IT1 bits are called as what? External interrupt mode selection bits. Means they can control the external interrupt INT0 and INT1. They will decide whether they are level triggered when they are 0. And when they are 1, the both interrupts are triggered at the edge. Next one is the interrupt in service flags. This means that if they are 1, both are 1, then they will service the present interrupt and they will not allow the new interrupt. Okay. Once they are cleared, make them as 0, then they will allow the new interrupt. That's why it's called as interrupt in service. And next one is the TR0 and TR1. They are used to start and stop the timers. And finally, TF0 and TF1 to indicate when it is reached to the final level. Once final level is reached, the TF0 and TF1 are become active. Means they are set to 1. Now, it's a little bit important one. Mode 1 operation of timer. I already told you there are 4 modes of operation of the timer. Mode 0, it acts as the 13-bit timer. It is not widely used. Then mode 1, it acts as a 16-bit timer. I told you already it's widely used. And mode 2, it acts as 8-bit auto reload. And mode 4, it acts as what? Split timer. Here, now we will come to the mode 1 operation of the timer. First, we will take the example of timer 0. Next, we move on to the timer 1. See here, operation of timer 0 in mode 1. Please remember, mode 1 means it acts as a 16-bit timer. How much bit? 16-bit timer. See here, this is the black diagram. This is the black diagram for the operation of timer in mode 1. See here, the first black is called as the crystal oscillator. We are called as the XTAL, crystal oscillator. Then please remember here, recall this C by T is equal to 0. C by T is equal to 0. Here, if the C by T is equal to 0, then it acts as the timer. If the C by T is equal to 1, then it acts as the counter. That's it. Very simple. Fine. So since we are discussing about the timer, here we set the C by T is equal to 0. Then there is an AND gate. Here it says one input from the C by T black, another input is from the TR0. TR0 is nothing but what? Timer 0. Fine. And now this is the TF0 and TH0. Finally, TF0. Please remember this one. Please remember. See here, it is 16-bit is nothing but it start from the D0. Fine. And like this, it is ending with what? D50. Fine. From D0 to D7, it is called as the TL0. From D8 to D15 is called as the TH0. See here, timer low 0, timer high 0. Totally it's a timer 0. These are the low level bits or least significant bits, that's why TL0. These are the most significant bits, that's the higher bits, that's why it's called as the TH0. That's why timer low and timer high. So this thing, TL0 and TH0. So here it is very easy to set the register here. Please remember, see now to operate the timer 0 in mode 1, in TMOD register, we have set the 8 bits from, see here, 0, 1. We have set the 8 bits as 0, 1. Why 0, 1 means, go back to the previous diagram here. Here, here, M0 and M1. If they are 0 and 1, if they are 0 and 1, here 0 and 1, it acts as the 16-bit timer. Here, these 4 bits in the TMOD register, they will decide the mode. Okay, now it is acting in mode 1, so that M1 and M0 become what? 0 and 1. Same thing here also, same thing. See, 0 and 1. Remaining, this D2 is indicated what? D2 is indicate what here? D2 is indicate C bar T. It decides whether it acts as the counter or timer. So I told you, if it is 0, act as the timer. If it is 1, act as the counter. Same thing here also. See here, D2 is nothing but C bar T. Now it's set to 0, it acts as the timer. Then D3 is nothing but what? Gate there. If this gate is 0, then we can use the 4 instructions, set B, and CLR like this. Okay, so that, so these two indicates the M0 and M1. This is indicate the C bar T. This is indicate the gate. So that the 4 nibbles is related to timer 0. Here also we are discussing timer 0. So that 0, 0, 0, 1. So when we are converting into byte, it becomes, see here, in the remaining 4 bits, you should not bother, because this diagram, see here, these 4 bits are related to timer 1. We are considering only these 4 bits. Okay, so that's why the remaining here, don't care. It should be either 0 or it should be either 1. So that when they are converted into a byte, so these 4 don't care consider as 0, and this 0, 0, 0, 1 is considered as 1, because just allot the power here to the power of 0, to the power of 1, to the power of 2, to the power of 3. In place of to the power of 0, what is there? 1 is there. So the to the power of 0 is equal to how much? 1. That's why finally when converted into byte, it becomes 0 and 1. See here, this whole complete portion becomes 0, and this portion becomes 1. That's why it becomes 0, 1. And we set the TCON register. It is also a 8-bit register. I already told that D0 to D7 set into a where D4 should be 1, remaining are the 0. Why D4 should be 1? Because go back to the here TCON register. In TCON register, where you find the TR0. TCON register, where you find the TR0. In D4, no. TR0 is nothing but what? Timer 0. So now we are dealing with the timer 0. That's why you should set the D4 as 1 here. See, the D4 is set as 1. Okay. So once again I will tell you, in TMOD register, 8-bit it is there. First 4-bit always decide the operation of the timer 0. Next 4-bit timer 1. We don't want timer 1 now, because we are dealing with timer 0. In timer 0, starting 2 bits, D0 and D1 nothing but M0 and M1 in that structure, bit structure. So that's set to 0 and 1. Okay, 0 and 1 is nothing but what? Which mode? Mode number 1. In mode number 1, it acts as 16-bit timer. Same thing here we are discussing. Okay, na? Then C bar T. C bar T is nothing but you should either set as 0 or set as 1. Here C bar T is nothing but which bit? D2 bit. C bar T should be 0 to act as a timer. So that we are set to 0. Then D3 is nothing but what? Gate. Okay. So when the gate is 0, we can use the instruction. When the gate is 1, we should use the what's called switches externally, hardware switches. Because gate D3 is nothing but gate. It's used to start and stop the timer. Okay. So that set the 0. So that internal instruction we can use. Okay. In TCON register, this starting from D0, ending with what's called, it's a D7. here the D4 bit is there, no? It will decide, it is called as what? TR0. So this TR0 become active, then it acts as the what? Timer 1. So timer 0. When TR0 is equal to 1, it acts as timer 0. That's why it should be 1, remaining should be 0. It may be IP1, IE1, it may be a TF1 or TR1, they should be 0. Only TR0 should be active. Now you can convert into bytes. What it will become? Byte convert. So divide here D7 to D4 and D3 to D6. See here 0, 0, 0, 1. It becomes what? 1. It becomes 1 because 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. It becomes 1. Okay. And here all are zeros. It becomes 0. So that we should not read it as 10H. We should read it as 10H. So this portion is converted as 1 when you are converting into byte. This portion is converted as 0. So that in byte we can write 10H. Okay. So now it's very simple procedure is there to act as timer 0 in mode 1. See here, very simple steps. Load the TMOD register with 01H. We are already loaded now. TMOD register, we are already loaded with 01H. First procedure is over. Load 16-bit initial value. See, in 16-bit timer, initial value is what? 00H. Why it is called a 16-bit? See here, this is the 4-bit, this is the 4-bit, this is the 4-bit, this is the 4-bit. How much totally? It's a totally 16-bit. It's the initial value, it is the final value. So that in between these two, you can set any to any value. That's why load 16-bit initial value into TL0 and TH0. TL0 means starting 8 bits. I told you the structure D0 to D15. TL0 here this side TL TH0. Okay. So that set this initial value to this TL0 and TH0. Now start the timer by using the instruction set to be TR0. See here, we are already TR0 is set to 1. TR0 is set to 1. TR0 where it comes? It comes in the TCON register. We are set to 1. 1 is nothing but, so it will start the timer. Because first we should fix a value. We are fixing a value between this minimum value to the maximum value. Now by using the instruction set to bit TR0. Okay, now the timer will start. So that after timer 0 started, after this instruction, the timer 0 will start. It counts from the initial value till it reaches the final value. What the final value will fix it? If you are fixed FFH, then it will count up to there. If you are fixed, for example, FFAH, it will count up to there. Okay, you start from the initial value and it will count up to the final value. So once it reaches the final value means it limits. Once it reaches the final value, it rolls back or it comes back to the initial value. Okay, already I told you when it is rolls back or it comes back to the initial value, immediately the timer overflow flag, that means TF0. In case of timer 0, the timer overflow flag is called as TF0. It's set to 1. When the counter reaches to the maximum value, okay, it will again come back to the initial value. So at the time, the TF0 becomes 1. So in this diagram, you can see here, this is the TF0. It becomes 1. Okay, so that when TF0 becomes 1, we should stop the timer because every counting is completed, the delay is completed. We should stop the timer by using the instruction CLR T0. Just compare here, set B T0, start the timer, and CLR T0, clear the timer or stop the timer. Okay, and finally, to repeat the next counter, to repeat the next delay, or to create the next delay, what we should do? We should reset the TF0 flag. Reset means it is 1. TF0 is 1 because overflow happening. Counting is completed. Now we should reset this TF0. Reset means it should become 0. How we can reset? We can reset by using the CLR TF0. CLR is always indicates what? It should be clear or stop. Okay. When you reset this TF0 flag by using this command CLR TF0, okay, then you can continue from the say step number 2. You load the initial value, then start the timer by using the instruction set BTR0. the counter will now start counting to the maximum value. Once it reaches the maximum value, it will come back to the initial value. Immediately, the timer overflow set to 1. Okay. To start the or to create the new delay, clear this timer overflow flag. Clear means reset this timer overflow flag by using the instruction CLR TF0. Clear timer overflow flag 0. Okay. Once you reset, then you should load the again next value. Okay. Like this, you should start from the again the step number 2. That is what in case of the timer 0 in mode 1. This is the first time. Then what? How the timer 1 act as in mode 1? See, nothing will be different in the black diagram. Everything is same except here. See here. In the earlier we mentioned TR0. Here we mentioned TR1. Because TR0 is related to timer 0. TR1 is related to what? Timer 1. That's why operation of timer 1 in mode 1. Fine. Okay. Here, this starting 8 bits is called as the TL1 and next 8 bits out of 16 bits because in mode 1 it accesses 16-bit timer. So the starting 8 bits are represented as TL1, timer low 1 and timer high 1. 1 is nothing but what? It's a timer 1. Finally, instead of TF0 in earlier, now it's a TF1. Timer overflow related to timer 1. Timer overflow related to timer. Okay. See here, it's a now. First nibble, we should make it as a don't care. Because first nibble means 4 bits related to which timer? Timer 0. Now we are come to the next 4 nibbles. That is the timer 1. Okay, timer 1. See here in the earlier timer 1, go back to the previous slides here. It should M0 and M1 should be fixed to what? 0, 1 to act as the mode 1. Here, similarly here also, here I'm fixed to 0, 1. Because in this nibble, this is the M0, correct? This is the M1. This is what? C bar T. This is what? Gate. Okay. It is don't care because it is related to that nibble related to timer 0. So here we should fix these two M0 and M1 to 0, 1. 0, 1 fix means okay, it automatically act as a which mode? Mode 1. Fine. Then C bar T should be 0. If C bar T should be 0, it acts as timer. I told you in the previous also. Here, if the C bar T become 1, it acts as the counter. Now we are discussing timer, not counter. That's why C bar T should be what? It should be a 0. It should be 0. Now gate. Gate should be always 0. Better to, because if you are program the what is timer to start and stop, the gate should be 0. If you put it as a 1, then you should start and stop the timer externally by using the hardware switches. That's why gate majority of time gate is always 0. So 0, 0, 0, 1 is the combination where the timer 1 acts as mode 1. Okay, now, see here, convert this into byte. See here, 0, 0, 0, 1. Apply this weights to the power of 0, to the power of 1, to the power of 2, to the power of 3. In place of 2 to the power of 0, 1 is there. What is 2 to the power of 0? 1. So that 1. Then don't care is nothing but you should consider as 0. So that it becomes 10H. Okay, when you convert it into byte. And now, next TCON register, it should be D6 bit should be 1. What exactly D6 bit? Go to the previous slides here, previous slides in TCON register. In D6, what is there? TR1. TR1 is nothing but what? Timer 1. Okay, na? So that in earlier, which in timer 0, we have put this TR0 as 1 because we were discussed about the timer 0. Now we are discussing what? Timer 1. That's why D6 should be what? 1. D6 should be 1. Same thing here I mentioned. D6 should be what? 1. Okay, in the TCON register, remaining are the zeros. When you are converted into a byte, it becomes 40H. How 40H? So starting 4 nibbles and the next 4 nibbles. Okay, same allocative power 2 to the power of 0, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. In the 2 to the power of 2 place, 1 is there. 2 to the power of 2 is equal to how much? 4. Same thing here, I am written 4. Okay, all are zeros. No need to apply the weights. Okay, if all are zeros, automatically it becomes 0. So that here it's a 4, there it's a 0, it becomes what? 40H. 40H. Okay. So now the procedure is almost same. Just see here. Once you know the previous timer 0 procedure, here also same thing will continue. Okay, see here. Load the TMOD resistor with 10H. I am already loading the TMOD resistor with 10H. Okay, then load the 16-bit initial value. Between these two values, you can load any value to the TL0 and TH0. Where TL0? TL1 and TH1. Here it's a TL1, 8-bit, and here it's a TH1, 8-bit. Load the 16-bit value. Here 8-bit load ಮಾಡಬೇಕು, here 8-bit. Okay, now then start timer by using the instruction set B TR1. Where is set B TR1? Here it's a TR1. Here it's a TR1. You are already set into a 1. You are already set into 1. So that the timer will automatically what? Start. Start the timer. Start the timer by using the instruction. By using the start the timer 1 by using the instruction set B TR1. Okay. Then it's actually it's a timer 1. Timer 1 by using the instruction set B TR1. After timer 1 started, it counts from the initial value and it reaches the maximum value. FFH. Okay, now when it reaches the FFH, it comes back to the initial value and TF1 is set to 1. TF means timer overflow back, it become 1. It become 1. Okay. When it become 1, it indicates what? Already the counting is completed. When TF1 is set to 1, stop the timer because the counting is completed. So stop the timer by using the instruction CLR TR1. Clear timer 1 means stop the timer. Okay. Once you stop the timer, then if you want to create the new delay for that counting schedule, if you want to create new delay, repeat the process. Reset the TF flag. Okay, means you should reset the TF1 flag. Reset means it become what? 0. Okay. Then go back to the step 2. Means load the initial value and start what? Counting. To repeat the process again, reset the TF1 flag by using the instruction clear TF1. Clear means earlier it was 1, now it becomes 0. 0 is nothing but you should start the new process by loading the another initial value. Okay, the diagram is almost similar. Wherever TR0 is comes, you should use the TR1. Wherever TF0 comes, you should use the TF1. Okay. This is about the how this timer 0 and timer 1 they will operate in the mode 1. Okay, means how they will act as a 16-bit timer. Okay. Now it's a mode 2. So here mode 2 is nothing but it acts as a 8-bit auto reload. 8-bit auto reload timer. What exactly auto reload? See here in this diagram, there is a little bit variation in this diagram. Okay, there is a TL0, timer low 0, 8-bit, and TH0, timer high, 8-bit. So in between this, there is a hardware switch is there. Okay, so what happens means in auto reload, again, see here, the first 4 bits, the first 4 nipper, it should set into what? 0010 because this is the M0, this is the M1, this is the C bar T, and it becomes what? Gate. Okay, set into a 10. 10 is nothing but it acts as which mode? Mode 2. See here, mode 2 is nothing but what? 10. Okay, that's why we set that here 10. 10. Okay, whether it is artistic counter or timer, now we are dealing about the timer. That's why it should be 0. Okay, if you set it to 1, it becomes a counter, but it should be a 0. Gate should be always 0. If it become 1, we should provide the start and stop externally. That's why it should be 0. Convert into a byte. So since all or don't care, it's become a 0. So now 0010 is nothing but what? It's a 2 because 2 to the power of 0, 2 to the power of 1. 2 to the power of 1 place, there will be a 1. 2 to the power of 1 is equal to what? 2. That's why it becomes 0 to H. Then the resistance of the TCON should be, see here, in place of D4 should be 1, remaining of the 0. Why D4 should be 1 here? Because in the TCON resistor structure, see here TCON. What D2 indicates, what D4 indicates? D4 indicates TR0, means timer 0. We are discussing here timer 0 in mode 2. We are discussing timer 0. We are discussing timer 0 in mode 2. You know, timer 0 in mode. That's why in the place of D4 there should be a 1. Means timer 0 should be what? Now it will start its operation. That's why in place of D4 we should use what? 1. Okay. So after this resistor settings, we should move to the what? Steps. Here, load the TMOD resistor with 0 to H. I am already loading this TMOD resistor with 0 to H. Then load 8-bit initial value. I already told you it's 8 in mode 2. Instead of 16-bit, it acts as how much bit? 8-bit. Okay, now in 16-bit, you people are writing 0000H up to what? Yup, H. If it is 16-bit. But now it acts as a 8-bit timer. That's why the initial value in 8-bit is 00H. 00H. Okay. And the final value is what? FFH. Half of the 16 is nothing but how much? 8. So that load 8-bit initial value, that means between 00H to FFH into TH0 into TH0, and in the mode 2 we should load the initial value here in TH0 only. We should what? Load the initial value, not to the TH0. So what happens is, why it is called as auto reload means, now we are loading the particular value into TH0. The same value is automatically copied to TL0. Please remember, there is a difference between the copied and load. There is a difference between the copied and load. So here, whatever the value are loaded to the TL0 is copied to the TL0 now. Is copied to the TL0 now. Okay. So that now the timer will start counting. How? By using the instruction set bit TR0. Because we are discussing timer 0, set bit TR0. We are already set the TR0 to 1. Now the timer will start counting. It will start counting. After timer 0 started, it counts from initial value to the till maximum value. Maximum value is how much? FF. Okay. It will count up to FF. When it reaches its limit, means FF final value, it roll back, same procedure, roll back from the FFH to the what? The initial value 00H. So here, the perfect meaning why it is called as auto reload means, now the TL0 initially the value of TL0 is loaded to the what? TL0 loaded. Now the original value of the TL0, beginning it is copied. Copied means duplicate value is loaded to the TL0. Duplicate value. Once time it is loaded. Now the original value from the TL0 is loaded to the TL0. 2 times loading takes place. That's why it is called as auto reloaded. Okay. Now TL0 is automatically reloaded into the original value of the TL0. First time it is copied, duplicate goes to the TL0. Now the original value is reloaded to the TL0. Reloaded to the TL0. That's why it's called as 8-bit auto reload. Finally, if you want to repeat the procedure, or if you want to repeat new delay, then reset the TF0 flag. Here you should reset. Reset means you should clear using the CLR TF0. Clear the TF0 and go to the step back 2. Okay. Remember, initially it is copied, value copied, original value still is in the TF0. Second time, the original value is copied to the automatically reloaded to the TL0. That's why it is called as 8-bit auto reload. This is about how the timer 0 operates in timer mode. In the next class, we will discuss how the timer 1 operates in mode 2. Previously we discussed it. Timer 1 operates in timer 0 operates in mode 2. Now timer 1 operates in mode 2. How it will act as. So we will discuss in the next class almost same procedure. Thank you for your valuable time.